Hello everyone. Welcome to Cryogenic Nanoelectronics EE226. It's a pity that we cannot see each other in person in the first class. I will see you again in the second week. But this recording is very important, right? So this is meant to replace the class next Wednesday on January 24th. So I will go over some logistic of this class. I will introduce myself. And actually, I won't talk about why we want to use cryogenic in this class, but I will talk about that in the second class. Okay, so about myself, I'm Hiu-Yung. I got my PhD from UC Berkeley in 2006, so I'm pretty old already. I actually at that time I did fabrication, device modeling. I went to the clean room. What I did was something called gate engineering. At that time, people are still using polysilicon gates for the transistor, and I studied how to use laser to melt the polysilicon gates to increase the doping to reduce the gate depletion, which we will cover a little bit in this class. And then studies the metal gate. At that time, people want to replace the polysilicon with metal gate to reduce the resistance and also reduce the so-called gate depletion effect. And the challenge of metal gates is to have the right work function. Right? So how do you make the right choose the right metal in the integration process? At that time, people are still studying how to develop 65 nanometer. But don't worry if you don't know what I'm talking about. In this class, I hope that after this class you will get an idea about it, right? And before that, I work on FPGA and chip design. I worked in Spansion for about 3 years on 45 nanometer flash memory integration. Flash memory is something what you use now with on your thumb drive, right? And Spansion actually was a very good company. It was a joint venture between AMD and Fujitsu. If you know the history, AMD was very good in non-volatile memory. Non-volatile means that even you turn off the power, the storage will not get erased. Nowadays, you take it for granted, like all your USB drive, solid state drive. Now technology are very mature, but at that time, this is something pretty. Not at that time. I mean, before 2000, this was something pretty exhausting, not commonly used. But Spencer make a wrong strategy. They try to develop something called NOR type flash memory instead of LAN type. NOR type flash memory allow you to access individual cell in a random manner, right? You can go to any location and read whatever you want. That is very good, particularly to store the instruction, the program. So it's very useful for set-top box. I don't know if we use something like this now, but like Roku or whatever nowadays, they all need this type of stuff. And they went to that direction. But unfortunately, they did not see that the big data is coming. Machine learning is coming. And now we are going to have a lot of data in the coming decade. And company like Micron or Western Digital before was SanDisk. SanDisk got acquired by Western Digital now. SanDisk, they all developed something called LAN type, right? So LAN, this is LAN type memory. And what Spencer did was the NOR type. LAN type is that you cannot do random access. Every time you need to read the whole page of memory. So this is, you can see that it's only useful for reading data, right? If you don't have a lot of data, that is not good. But who knows, right? Suddenly we have this cell phone camera. We need a lot of data, and that's why this one win, right? And actually, expansion went into bankruptcy protection. Now, I want to say that it's not just the law, the marketing strategy went wrong, right? Also due to many other reasons, including to the meltdown of the financial crisis in 2009, right? But definitely there's some management problem. Anyway, then I work in Synopsys, which is an EDA company. Right now, it is very successful. I actually left in 2018 and sold all the stock. If I did not do that, I would have been very rich, right? When I joined in 2009, the stock was $18. When I left, it was 75, and today it's more than 500, right? But on the way, I keep selling, so that's why I am never rich. I can only be a teacher. And another thing that actually I forgot to update this slide. I'm an associate professor now, and so I joined SJSU, and I work on different type of simulation. I work on different type of research, including machine learning for physical simulation, quantum computing. And some of you, I know you are from the MSQT program, right? And that's why you come to take this class, because this class is an elective. Now you will see why we want this, because cryogenic electronics is very important for quantum computing. So I've been teaching different classes. E124 is the undergraduate core analog circuit. E224 is the high-speed digital circuit. 222 is a class that I created to do the emerging memory. 225, Introduction to Quantum Computing. If any one of you are interested, you can take it this fall. And 227 is Quantum Computing Architecture. I will offer it again next spring. Okay, and this class is EE226. All this, except EE226, I have uploaded all the teaching video on my YouTube. So you can take a look if you are interested. And this is my web page. Okay. I spent some time to introduce to you, because I think it's important for you to know who I am. And you know my background, you know my limitation and what I might be good at, so you can make the best use of me. In terms of research, I always look for self-motivated students. The most important thing is I always try not to pay until the funding is available, right? Or the student really show that he or she is committed. But usually, overall, they get a good overall experience, because we usually have publication. So I always look for students to work on cryogenic IC design, quantum chip design, machine learning and programming, device and circuit simulation, right, and quantum computing. Particularly if you're undergraduate, female, or underrepresented minorities, I really encourage you to try, because usually they are less represented, because somehow they are not aware of this type of opportunity. So it would be great if you are interested. I had many good students before. They are very self-motivated, and they are tough people, and they are very successful after they graduate. So if this were an in-person meeting, then I will ask you to tell me who you are, your name, right? But when I ask this, I actually want you to ask yourself, right? Why are you taking this class, right? Who are you, right? Who am I? Why am I here, right? So think about that. You need to ask yourself every moment in your life. I do not do that. I'm not good enough in doing that. But once you have the time, if you really ask why I'm doing this, why I want to do this, the main thing is that you set the right goal. For example, why you take EE226? Maybe I cannot find any other suitable class. I just need to get 3 more units to graduate. Fine. Whatever goal you have, then you work towards your goal. For example, I just need to get MB to graduate. Then fine, you don't need to come to the class every day if you think you're okay, and do all the assignment, watch all the YouTube, and then just come to the exam midterm, right? If you are your confidence in yourself, and get a B and go. Use all your leisure time. Either if you think dating is important, go to dating. Having your startup company is important. Plan for that. Hanging out with friends is important. Do that. Maximize the goal of your life, right? The most important is that you know what you want. Do not wait until the last minute and then say, hey, actually, I really want to get an A, but that will be too late. Or your goal is not, you don't care about the grade, you actually care about the knowledge. Then you really need to think, how should I get the most from this class, right? And I can tell you the best is that try to make the best use of me, but not asking me to do your homework, but keep asking me questions, because it is my responsibility to answer your question, right? Even I am impolite, even I show that I'm impatient, but you still can ask, because I cannot discriminate you just because you ask a lot of questions. I still need to give you a fair grading. So why don't you make the best use of me if you what you want is to learn something, right? And if you find the research align with your goal, yeah, you can do research together, right? So don't waste your time and opportunity. So in this class, of course, my goal is to help you to learn the basics of nanoelectronics, including the layout skill and circuit design, right? I also hope you can get interested in this domain, because when we talk about the cryogenic electronics, I will try to link it to its application. Not that explicitly, but you will see that why we need the cryogenic transistor, the design skill of it, and why we need the low noise amplifier at cryogenic temperature. And you will realize that, oh, it's used to interface with the quantum computer interface, or you may realize that it is to manipulates the quantum dot, right? All these things will be some water pedal in the future. You can link them together. So I hope that will be useful. And definitely, after all, we need to be realistic, right? Why I'm here? Of course, I get paid. And why are you here? You get the grade that you deserve, right? So if you work hard, I see by reflecting in your assignment, midterm, and final and project, I will give you a good grade. I'm pretty lenient actually, right? So really, if you don't get a B or above, then it means that you must have missed a lot of assignment, or you really did not pay attention. Okay. And of course, I enjoy the process, but I always have students very keen in learning, talk to me, and actually I learn from them. And in our class, to be frank, I have a student who is a guru in IC design, so I know that he's going to challenge me a lot. And then learn from you, right? And your goal, please learn the basics. I really don't want you to just get a grade and leave. I really want you to learn something, right? Get the grade you deserve, and also build a network. We have people from different programs, quantum technology, electrical engineering. We also, this year we don't have people from Open University, but anyway, the one sitting in front of you, left and right and back, they probably go to different company in the future. One may be in Apple, one may be in Samsung, one may be in a startup, and the one after you, behind you, maybe go to a PhD program. Now, those are the network that you have, right? Because now you are the good student, your classmate of each other, you trust each other, right? And in the future, you need help, have a course, SJSU alumni. That is a very important network when you want to switch company or whatever, right? So in the project, I'm going to assign you as a group of two. If it becomes odd number, maybe I will have one group with three, or one of you just work by yourself. So try to build a network, right? Spend some time. You may feel it's a waste of time. When I was young, when I was a student, I also feel that it's a waste of time. Why don't I just finish the project and go home, right? But no, even many of you are already graduate student. I'm pretty sure some of you still think in my way. So build a good network. Network is very important. So let's talk about the logistic, right? So we use Canvas, and again, this is not in engineering building, it's the Dewey Hall, and it is pretty late, 7:30 to 8:45. Before that, I have the office hour. Now to be fair, I put this just for formality because I need to put office hour. But if you want to talk to me anytime, just shoot me an email, right? If you can do it before at least 3 hours earlier, let's say before 1 p.m., you say I want to meet you at 4, right? I might not be in the office, but at least we can have Zoom, right? So always just feel free to email me. I would be very happy to talk to you. If I'm very busy and show that I'm a little bit impatient, ignore me, okay? That really doesn't matter to you. Just treat me as a stupid people, right? Ask the question and leave. So, but however, I need to be very clear. All our communication will be given in the lecture and Canvas. You need to make sure you can access Canvas, right? Ask question anytime during lecture, Canvas, email, office hour, or appointment, right? So I want to make the responsibility very clear. It's your responsibility for you to contact me if you have questions. Right? I'm not a good teacher. I'm not going to email you every day or grab you and say, do you have question? Okay? And it's my responsibility to help you. Try my best, right? I'm not doing assignment for you, but I should guide you. I should answer your question. Okay? I'm not the guy, at least I'm not so bad that I say, I already had the office hour, you don't come, that is your problem, I'm not going to answer, or delete, just wait for many days to answer your question. No, I respond very fast. Now I'm busier, but I should still be able to respond within the same day. If usually I respond within 1 or 2 hours. So really try to make the best use of me, okay? Again, Canvas is very important. You need to make sure that you can access, you can check all the announcement I put there. I prefer you to email me if you have question, but if you want to use the messenger or messaging feature in Canvas, it is also fine, right? So no problem, just do that. But definitely everything go through Canvas. Okay, make sure you can access it. Regarding the syllabus, remember we have a so-called SJSU official syllabus tab on the left in your Canvas. Now every class need to follow the same format. So does this class. Read them. Right. Our department head, when I was hired, he always told me that this is the contract between you and me. If we have your argument, we will refer to the Canvas, right? But I hope that we won't end up at that. If there's anything not clear, let me know ASAP. Okay. Otherwise, sometimes for fairness, I need to stick to that. We don't have textbook because indeed, there's no textbook that cover all the topics I want to talk in this class. But we have some reference. No need to buy them. Most of them should be available from the library. And some of them actually have a digital version if you log in using VPN. Okay, so no need to buy them. These are the book that I will talk about. You don't really need to read them, it's quite extensive. But if you're interested, go ahead. For example, this one talk about the cryogenic equipment. Right. This one talk about the quantum dots, quantum transport. Again, you don't read the whole book because many of them are not relevant to this class. But quantum phenomenon appear, right, only at low temperature. Most of the phenomena. That's why quantum dot in quantum transport, they naturally will look into the what they call the diamond diagram, and then all those things they usually need to occur at low temperature. And why? We will discuss this later. Right? This is a collection of paper, if I did not mistaken, about all the device nature when they go to cryogenic temperature, low temperature. Okay, and because we are doing RF, definitely you first need to know the basic analog circuit design. Right, this one we did not use in EE124. This is for EE223, right? But you don't need to have those basics. I will start from the basics, okay? And then RF1 is the one that used in the we are going to use for the LNA design. Okay. Now, like this class, like what I'm showing here, I will try to post the annotated slides 3 days before the class. No guarantee, right? But the point is, do not use this for study. Once I given the class with a lot of annotation, then and I should do it on the same day, right? Then I'm going to post it again. Then you use this to do the study, right? I post the first one just in case some of you like to have a template and to write down what I said, right? Some of you think my handwriting is really ugly and messy, right? One excuse for me for saying that is that I want you to rewrite yourself, because by only doing that you really learn something, right? Instead of just looking at what I wrote. So that's my excuse. Of course, every semester I get complaint from one student saying that my notes are messy, but it should not affect your study. It only can make you better, because I'm going to record all the lecture and put them on YouTube. So if anything you read it, you forget what it means, then watch that part of YouTube, and that is the best way to help you to study, really, in my opinion, right? So I hope that you appreciate that, right? But sometimes I may fail recording. Sometimes my computer might fail. So do not expect that it will always be there. So this is not something I promise you. But usually, at least success rate is like 95%, right? So, but don't complain me if one of the YouTube did not have the sound recorder, or it just corrupted. I also have a Google Anonymous survey form. If you have any opinion on this class, whether good or bad, feel free to write there. I cannot really fulfill all the requirement, right? Sometimes the student might say, I think the project should be worked by 3 people, for example. Then I'm not going to change it, but I'm going to respond in the class, explain why I'm not going to do that. Either I don't have the resources, either I think this is not a good idea, I will respond. So write down the comments, okay? Regarding the grading, you look at this structure. Assignment is 30%, right? Midterm final is 20%. What does it mean? And project is 30. So you see, this class really grade based on your effort in the participation. If you do all the assignment, you do all the project, and if you care about the correctness, when you do it, you discuss with your friend, or even come to me, ask me to check. I might not check thoroughly, but at least I will briefly tell you, well, this is completely wrong, or this looks okay, right? Then you already have almost 60% if you just fulfill all the requirement, right? And then the rest is with a cheat sheet. Always cheat sheet exam is easier than open book, I can tell you. So do not worry when I say it is cheat sheet. The chance you get a good grade is pretty high, right? So I hope you appreciate that. Also, that's why my requirement on this class is that you are willing to spend time, okay? And these are the breakdowns. And I expect you to get at least 79% on average, because I think for a graduate student, B is very important, right? For undergraduate, congratulations, I'm grading on the graduate student scale also, right? For undergraduate, B is pretty good already. But for graduate student, if you get a B, you are just, the 3.0 is what you need in order to stay in the long academic notice, right? In the past, they call it probation. Now it's called academic notice, right? As long as GPA is more than 3.0, you are okay. I think, for example, you cannot apply for ISA, the grader position in our department, if your GPA is less than 3.0, etc., right? So I hope all of you work hard to get at least 80%, okay? And here I need to be very strict, very clear. I want to be very clear to all of you about the submission. I am a very strict people, because I came from the industry. I worked for 12 years. If you miss the deadline by 1 second, you cannot sell your product. If you cannot help your customer by do it late by 1 second, you will get complaint to your boss. So here we try to grade everything linearly. We try to help you to be successful. But I hope you, as a graduate student or a senior undergraduate student, you will follow the rule strictly. No excuse. If you submit before 11:59, not 11:59:01, okay, not 1 second after it, you get whatever you score. You score 90%, you get 90%. But if it is within 3 days after the deadline, you only get half of them. Now, this is not the practice in the industry. Your customer won't say that you cannot deliver the parts to me, but you deliver 2 days later, I still give you a half of the orders. No such thing. You are out of the game, okay? But we still give you opportunity. If it is after 3 days, I'm sorry, just 0%. No bargain unless you tell me that something urgent happened, but I need proof, okay? But still good to talk to me, okay? There should be a proof. For example, you say you're sick, then doctor note. I do not accept just today is the deadline, and then at the afternoon you say I don't feel well, but then you don't have doctor's note, right? Because it's very simple, right? If you were another student, you see that I let you still give you full score when you are late, how would the other student feel? The other student might have sacrificed dating or going out with friends or giving up the preparation for another midterm or giving up another assignment so that that student was not able to get a very high score in order to meet the deadline. And then now I tell that student that I give you extension for no reason, right? That's why I follow it very strict, okay? So, but however, this is not company. We are not completely bloodless, right? If you have any reason, just talk to me. But I hope that you really understand it need to be a valid reason, right? Talk to me, whatever concern, and don't need to talk about your privacy, confidential thing, right? If we really need verification, we can ask the department to verify or ask the school, because if something big, they must have some record, right? So don't worry, but let me just make this very strict at this moment, okay? So what are we going to study? Monday no class. This class is online. We are going to first look at the bulk MOSFET, the regular planar MOSFET. We'll look at their cryogenic property. What happens when it goes down to 4.2 Kelvin, right? Some of you might not have a strong background on transistor. I am still going to spend quite some time to explain the basics, okay? Then I talk about SOI, silicon on insulator, its cryogenic property. FinFET, which is a three-dimensional transistor, is electrical probability. I also want to talk about the layouts of FinFET. Many of us don't have this experience because we just use the 45 nanometer cadence PDK. So I will just share some experience with you. Again, I'm not expert, but I know the device of FinFET. I'll tell you how it's related to each other, right? Then we look at high electron mobility transistor. I won't go into detail. That is not silicon, but it is very useful because it has very low noise. And we look at property is quantum effect. And then we finish the device part. Quantum effect, like quantum dot or whatever, right? We finish the device part. We will have midterm. Then we will go to the circuit part. We start with noise analysis. So yes, some of you have learned it or learning it in another class. So you can see this is maybe a little bit overlap with other classes. If you still want to take this class, you can treat this maybe some easy low hanging fruit for you, right? You can spend time to start your project. But I do want to go from basics so everyone knows everything, right? Then we have spring recess. And then we talk about the low noise amplifier at low temperature. And then the qubit, quantum qubit, quantum computer control and sensing circuit. Okay. And then you need to do the project along the way. And we only have 4 assignments. And this is the exam time. Make sure that you don't have conflict or you're not traveling or whatever. Okay. Now, for the project, there are 2 choices for you, right? You can decide later because the project only start in late March, right? Right before the spring break. You can do something called TGAT. You will learn it in the assignment one. Technology Computer Aided Design. What it does is that it solves the system of equation of the semiconductor, Poisson equation, carrier continuity equations, couple them. So if you have any new idea of any new transistor, you can just draw it and then you will tell it how it would behave. Okay, and then you can do the simulation. But this time we want to go to low temperature. So low temperature has bad convergence, but that is not something I ask you to fix it because this is a difficult problem, right? You just use it as a tool, but you will run into this problem. But more importantly, we will use this to understand the physics or explain the physics at low temperature. For example, in this paper, right, there was a student published with me 3 years ago, right? It's not from this class because this class was not there at that time. We were able to match the experimental data from 300 Kelvin to 5 Kelvin by turning on some of the new model, right? If you don't like this, I guess many of you don't. You can go ahead to do 45 nanometer or 40 nanometer LNA, low noise amplifier. This is not my paper, right? Just from a journal. And what you're doing is this part. This is a quantum bit, right? And then we send a signal to it and measure the reflector signal. Then we know its state. We need to amplify it. We use low noise amplifier with mixer, low pass filter, analog to digital converter, and here you have all this attenuator, phase lock loop, etc. Right? So there are lots of things to study. I actually not expert in this, but we will only talk about LNA. You learn this in other classes, right? I know that. But here we try to look at the cryogenic aspect, mostly about the noise. Okay. So you can choose both of them. And actually, in the first time, turned out everyone used 45 nanometer because 40 nanometer layout is pretty time consuming, right? In this class, you need to do the layout, right? You may say, wow, that's so tedious, but that is a very good point for you to show off when you go for interview for circuit design. For those who are doing circuit design, you really should do post layout simulation. I think post layout, this is the only class asked for post layout simulation. Okay. So prerequisite is graduate student standing or instructor consent. That is okay. So how should you study? Right? All this simple thing I keep repeating, but I only repeat once, and in future we refer to this slide, and you need to follow. Every unit you're supposed to spend 3 hours a week. So if you think that you cannot follow, you ask yourself, did I spend 9 hours? Because this is a 9 hours class. Now, our class lecture time is only how many? 2.5 hours. So you still have 6.5 hours. You may use some for doing homework, some using for project. Definitely, it means you still need to spend quite some amount of time to study, right? So if you cannot follow, then please really follow this, right? This very makes sense, right? Because you probably will take 12 units to 15 units, right? 12 units refer to about 36 hours. A full-time student makes sense. A full-time is 40 hours, right? So you really need to do that, right? And if you have problem, just talk to me. These are some of the evaluation from my previous class. I'm pretty proud myself. Most of my evaluation are good, but here I show you some bad one. I first show you some good one because that is relevant, right? I'm not bragging, but I want to make you make the best use of this. Very engaging and interactive with our class. Encourages us to ask questions, make every attempt to make sure we hear and understand important concept before moving forward. You will see that. So that some of you will feel is a little bit slow. It is true if you are very advanced already, right? But why don't you take this chance to help me to answer question or to ask to think deeper, to ask more question. And if you don't know cannot follow me, please go ahead to ask question because I can guarantee maybe another 1/3 of the class has the same problem as you. Please ask questions and make the best use of me, right? They say I'm approachable for assistant, then approachable, then take advantage of this, okay? I will let you know if you ask too much, so keep asking, right? She said I'm adaptable to teaching style. Yeah, I will try my best to adapt myself to you, right? But not always I can do that. Some say that I'm very blunt when returning the midterm outside of classroom. I'm not your friend when it comes to grading, okay? I might smile more next time, but I guess the reason is this. Maybe probably some student ask me to regrade it and then give a higher score, but I grade everyone in the same way. So I always refuse unless I make a mistake, okay? So I want you to, instead of trying to ask professor to give more score, try to understand why it is wrong and learn it and get a higher score in the next test, okay? I'm not going to be lenient in late policy because they are very lenient already. You will realize that later, okay? But we need to be very strict about deadline. Okay, I don't want to discuss about the deadline. Of course, if you have some personal difficulty, we can discuss. But let's say we need to see what type of personal difficulty, right? But if you really have difficulty, come to me. We can discuss. Okay. I think that's it. Maybe if you have time, take a look at this video. This video is about talking about how to work hard. I really love this video. Take a look. Basically, it say that there's no genius. All right, you just work hard. The 5 minutes video, and when you are successful, try to help the others. That basically is the important part of the life, right? If you want to be meaningful. Of course, I cannot do it yet, neither, right? I always think about myself. Okay, so that's all I have for this session, and I will see you in the second class. Thank you very much.